Hello all, this is Dr. Rukumar. Welcome to Masterclass series of Dentospedia. Today we're going to deal with the first session of oral radiology. And today's topic is X-ray production. And before diving into the topic, I want you to understand a few basic points. Okay. And this is the planetary model of atomic structure. Okay. And this is the atom. And we have nucleus at the center. Inside the nucleus, we have protons and neutrons. Protons have the positive charge, whereas neutrons, they're kind of electrically neutral state. Okay. And we have electrons revolving around the nucleus in orbits. Okay. And these electrons have negative charge. And this is all about planetary model of atomic structure. What is atomic number? It is represented by the letter Z. It is nothing but the total number of protons in an atom. What is atomic weight? It is the number of protons and neutrons in an atom. You might have seen the atomic number and atomic weight in periodic table, right? When we say an atom is stable, it means it has not lost or gained electrons. Okay, and these atoms are, they don't have any charge. Okay, and they are kind of electrically neutral state. And when atoms gains or loses electrons, it is converted to ions. Okay, and this process is called ionization. Ions are charged and unstable. Okay, whereas atoms are neutral and stable in nature. And when an atom loses an electron, it attains negative charge. Okay, the ion has negative charge, and that ion is called anion. And when an atom gains an electron, it is converted to ion with positive charge, and that ion is called cation. Okay, that's the difference between anion and cation. In this slide, we are going to discuss the forces of attraction between the nucleus and the electrons. So we have learned that electrons are revolving around the nucleus, right? So nucleus exerts some kind of electrostatic forces of attraction on the electrons. Okay, and electrons closer to the nucleus, they experience more forces of attraction when compared to the electrons present in the outer orbits. Okay, in this example, we have three electrons A, B, and C, and when we arrange an order on the basis of nuclear forces of attraction, it will be A greater than B greater than C. Okay, A experiences more forces of attraction from the nucleus, and C experiences the least. Okay, and when we want to kick this electron from its orbit, we need to apply some external force, right? We need to counter these nuclear forces. Okay, and because A is having more attraction forces from the nucleus, we need to apply more forces, the more external forces to kick this electron A from its orbit. And because C is having the least forces of attraction between the nucleus and the electron, we can apply the least external force to kick this electron out of this orbit. Okay, so that's an order: A greater than B greater than C. So if we want to kick this electron A, we need to apply the highest force, and if we want to kick this electron C, we can apply a least amount of force to kick this electron. Okay, and this is the electromagnetic spectrum, where multiple radiations are present in an order of wavelength. Okay, and we have radio waves, microwaves, infrared, visible light wavelength. Okay, visible light frequency. Okay, and we have ultraviolet rays, X-rays, and gamma rays. And radio waves have the longer wavelength, that is longest wavelength. Okay, and they have low frequency. You might have learned, right, the wavelength and frequency are inversely proportional. So whatever the radiation, if the radiation has, they have the highest wavelength, we can say they have lowest frequency. Okay, in this electromagnetic spectrum, radio waves have the longer wavelength but lower frequency, and gamma rays has shorter wavelength, and they have highest frequency. Okay, and X-rays are present in between the ultraviolet and the gamma rays based on their wavelength. Okay, and X-rays are kind of ionizing radiation, and we have visible wavelength, visible light, right, from between the wavelengths of 400 to 700 nanometers, and this is all about electromagnetic spectrum. And these are the various parts of X-ray setup. We have extension arm, we have outer casing which contains X-ray tube. That's the main part, right? We have tube head, we have control panel to control the settings, and we have exposure shooting button for the technician. And what's inside the external casing? And we have the X-ray tube. This is the main part of X-ray tube where X-ray production will be generated. And what are the various parts of X-ray tube? We have mainly leaded and vacuumated borosilicate glass tube. We have cathode, also called negative electrode, and here tungsten filament is acting as cathode. We have molybdenum focusing cup, and tungsten plate is acting as anode, also called positive electrode, and we have copper block. So this is the block diagram of various parts. So this is the outer leaded glass casing, okay, borosilicate glass casing, and we have the cathode here. This is the tungsten filament, okay. This is the cathode. We have the molybdenum focusing cup. Here we have the anode, that is tungsten plate, and surrounded by copper block. Cathode is connected to the negative terminal, and anode is connected to the positive terminal of the circuit. And there is a small window here. There is no lid here, right? There is no lid here, and this is where the X-rays exit from the X-ray tube. Okay. And what are the purposes of various parts? And what is the purpose of leaded and vacuumated glass tube? It is tough in nature. And why it is vacuumated, right? Why you are evacuating the air molecules? Because it removes the air interference for high-speed electrons. Here in the X-ray production, in the initial process, X-rays are, the electrons are produced and they have high speed. And we don't want air molecules to interfere the high-speed electrons. Okay, that's why we are evacuating the air molecules. And also, because of evacuating the air molecules, it prevents oxidation burnout of cathode filament. Okay, and why we are using lead here? So it helps in radiation control. And tungsten is acting as both cathode and anode, but in different shapes. Okay, and we have molybdenum focusing cup. Molybdenum is electrostatically negative in nature. So we have discussed, right, in the process of X-ray production, we have high-speed electrons are generated from cathode, and molybdenum, as it is electrostatically negative, it helps in focusing of electrons, or we can say the molybdenum focusing cup, it directs the electrons towards the anode. Okay, and what is the purpose of copper? It helps in heat dissipation and it is a good conductor of heat. Okay, and why tungsten is used as both cathode and anode? So there are mainly 4 reasons. It has high atomic number, that is 74. It has high melting point, that is about 3422 degrees Celsius. It has high thermal conductivity and low vapor pressure. So these are the reasons why tungsten is used as both cathode and anode. And I want you to understand, I don't want you to confuse in between the two terms, cathode and cation, anode and anode. So cathode is nothing but a metal that is connected to the negative terminal of the circuit. Okay, and anode, they're also kind of metals. They're connected to the positive terminal of the circuit. Cations or anions are nothing but ions having both positive and negative charge. Okay, and they're kind of a different in nature. And coming to the fundamental principle of X-ray production. So this is the flowchart of the whole process. The first step is we heat the cathode, and because of the heating of cathode, the electrons are, they kind of ejected from the cathode, and they have high speed, okay, and they're directed towards the anode. And because of the molybdenum focusing cup, it kind of acts like a boost for the electrons. It increases the speed of electrons, and these electrons hit the target, that is anode, at the focal spot, and then X-rays are generated, and these X-rays, they exit from the glass tube at a certain point, that is called glass window. At the window there is no lid, right? So that's why X-rays are getting exited from the glass tube. And also these X-rays try to exit from the glass tube from some other points, but here we are having lid, right? So lid don't allow the X-rays to pass through it, and it helps in focusing the X-rays to exit only at the window, okay. And during the production of X-rays, we have mainly two kinds of radiations produced. We can say two types of X-rays are produced. There are mainly Bremsstrahlung radiation and characteristic radiation. Okay, consider two high-speed electrons are coming towards the anode. So this is the anode. Okay, and these are high-speed electrons coming from cathode, A and B. Okay, and electron A having high speed, okay, and they kind of attract towards the nucleus, but it doesn't hit the nucleus or electron in that atom, and because of its high speed, it kind of deviates from its original path and enters into another atom. So during the process of attraction towards the nucleus, it is kind of there will be energy loss, and because of the energy loss there will be radiation produced, that is called Bremsstrahlung radiation, which is also the in German it is called the Bremsstrahlung radiation. In German it is called braking radiation. So here the electron A, during its path towards the nucleus, and because of its high speed and nuclear forces of attraction, they kind of counter each other, and they kind of slows down during its pathway, okay. And because of its slowing of speed, there will be energy loss, and that energy loss will result in Bremsstrahlung radiation, okay. And these electron, they don't hit with another electron, they don't hit the nucleus, they kind of they veered off in its path, and they enter into another atom. So this is a situation of A electron, and in the process we have the production of Bremsstrahlung radiation. And consider another electron B, they directly hit the electron in the target atom, okay, and they kick this electron out of its shell, and because of there will be vacancy here, the outer orbit electron, they try to jump in from outer orbit to inner orbit, okay, and here there will be vacancy here, and the outer orbit will try to enter here, and this goes on. And this process, during the process of jumping from outer orbit to inner orbit, there will be energy production, okay, and this energy will result in a radiation called characteristic radiation, okay. These are the two types of radiation, Bremsstrahlung and characteristic radiation. And for the imaging, Bremsstrahlung radiation is important, okay, and characteristic radiation doesn't produce any kind of an image in films. So that's all about X-ray production. Hope you understood very well. Thank you.